All right, guys, welcome to the assembly process. I assume by this point you guys have taken your old fan apart and just bought new parts. But either way, this is the first step to getting your EDF Dynamax up and running. So my preferred first step for the assembly is to build the stator housing. For demonstration purposes here and also to keep my video short, I've assembled most of this already. Relatively self-explanatory, especially because you guys will have to go through the trouble of removing all of these stator blades to pull the stock center body out of your old glow fan. So the assembly process for that is pretty straightforward because we simply put the stator blades back in there and we tighten them down. A couple of words of advice here. I don't recommend tightening these screws down completely until all the stator blades are in there. And once they're in there, treat this like a spoke on a wire wheel. So never fully tighten one side down without at least having some torque on the other end as well. So what I'll normally do is tighten one screw down and I'll go to the opposite side, tighten this one down, and I'll just kind of work my way all the way around, always making sure to go opposite from one end to the other. And I find that that'll usually help to keep this thing shaped as close to a circle as possible. Now realize there will be a little bit of deformation and there's just not a whole lot that can be done with that. Okay, moving along here, we've got our long stators, we've got our short stators. What I like to do is start with the long stators. I'll go ahead and slide them into position, which should be an easy process because by this point, at this point, there's plenty of freedom to move the center body around to get these stators to fit, since you'll only have the two long stators in there. Once they're in position, go ahead and use the hardware that's included with the conversion kit. So find these two of the longest screws that you can in there and go ahead and drop them into the center body inside out with the head of the screw sitting flush or slightly below the chamfer on the inside of the center body. Go ahead and do this on both sides, and this will ensure that the center body is not going to move around as we attempt to rebuild or build the remainder of the fan. For the small stators, a couple of potential problems to point out here. For a brand new fan with brand new parts, it is possible that the last couple of pieces here are going to cause some problems because they haven't had the compression on them that an older fan might have experienced. So to help with that, a couple of things we can do. We can sand the bottom surface here on the small stators, and that should take just enough away to be able to slide them into position easily. If you guys don't want to do that, we can just kind of force it in there, which is fine, but just be careful. Don't break the stator in trying to do so. But the shroud being plastic, it will deform enough. You know, we can squeeze it and just kind of push these stator blades into position. Another method that we can use is to put the stator blade in there at an angle. Just make sure that it's sitting up against one side here. And then once it's in position, we can attempt to rotate it around one of the edges here. And that should work out if there is sufficient space, which there usually is, but it will be a nice tight fit. So it just kind of snaps into position just like that. And that's pretty much it. The next step is to start tightening down all of our screws. So for, once again, demonstration purposes here, because I have most of them or all of them in there with the exception of this one screw, we'll go ahead and line up the blade, insert the screw in there, and from there just go ahead and start tightening it down. A lot of screws to work with here, so I recommend using some sort of driver to do this. Okay, the final step to finishing our fan shroud is to finish the mounts and get them installed. The problem with the stock mount, which will look something like this, older versions might be a little bit different, but for the most part, this is what they'll look like. The issue with these is once they are installed here in position, because I am attempting to use these screws from the inside out in order to give this fan some structure, I have to be able to put the nut here on the outside. Now with the old stock mount, that is not going to work out because I don't have enough clearance between the screw here and the mount to be able to get this nut into position and to tighten this thing down. So the best and the easiest solution I came up with was to basically put a groove that's wide enough to be able to accept that nut. And that is going to look something like this. The tool that I use to make this happen is a Dremel with a cutoff blade on the front here. This is a heavy duty blade. I believe I purchased it from Harbor Freight for a couple of bucks. So very handy to have around for many purposes. The next step to doing this is to mount your mount in a vise. That would be the best case. The next best case would be to clamp this down on a table so that it cannot move as we attempt to make the groove using our Dremel. Very important to do that because aesthetically it will look good if you guys can prevent the mount from moving around, and also it'll just make your life easy as we attempt to do this. So once it's in position, really the key thing here is to just ensure that you have a perfect 90-degree angle to the mount as we dig this groove in there. Take your time to do this. Don't be in a rush, and I promise the results will look very good. Once that's complete, test to make sure that the nut and the hole in that nut lines up with the hole that's drilled into the mount. In order to install our modified mount onto the fan, we're just gonna put it into position. Just keep in mind that if you guys are attempting to have one particular side of the fan facing up when it's installed in your aircraft, just make sure that that portion is on the right side as we put the mounts on here. It'll just save some trouble later. Okay, with the mount in position, we'll go ahead and just drop the nut in there, and then from there, basically just feed the screw from the inside. And it should catch, assuming we've done a good enough job here with our groove. And that's pretty much it. From there, we just need to figure out a way to tighten it down. I use this handy dandy low profile screwdriver, and that's pretty much how I do it. One thing you guys can do for aesthetics, or if you just need more clearance here to mount this in your airplane, is to cut off any excess that might remain of that screw, because they are a little bit longer than they need to be to make the assembly process easier. Okay guys, moving on to the next step with our completed shroud. We're gonna go ahead and fix the heatsink onto our motor, and then we'll install the motor into the center body. Please take note here, this is not the same shroud that you guys saw in the previous segment of the video. I did this a little bit out of sequence, so I had to use a different shroud because the other one is already assembled and being used. Additionally, the motor I'm using here to demonstrate the install, this is a 73mm long motor, vice the 68mm that was shown in the previous segment. And the reason why I mentioned that is when I go to install the heatsink will sit flush with the back of this motor. On the 68, that is not the case because I don't have the full length that I need to be able to do this. So on the 68, the heatsink will actually extend slightly further behind the aft end of the motor, and that is completely normal and acceptable. Okay, moving on. The heatsink, when you guys open up your conversion kit, will come with all 6 M3 screws installed, but not completely tightened down. This is just a quality control check on my end to ensure that the machining on this is correct, because I have found some pieces that were not properly machined. So once we get to this step, the first thing you guys want to do is go ahead and take all the screws out. Okay, we'll go ahead and set those aside for now. We're going to need it here in a few moments. and you guys will have all 6 of those, of course. Okay, we're gonna go ahead and apply our heatsink compound next. You guys can expect to receive 2 of these packets per conversion kit, 1 for each side of the clamshell. The best way to apply this is to snip open the packet there, squeeze all the compound out onto the inner surface of the heatsink, and then spread it out, ensuring that the entire surface is completely covered. We do not need... All right, guys, I'm not actually going to apply the heatsink compound since this is only for demonstration, but at this point I would have done that and set those aside for the moment. Okay, next we're going to work on installing our motor into the center body and determine exactly how the heatsink is going to be installed onto the motor. What I recommend doing here is paying close attention to where the wires are for the motor. Orient them in the direction that you guys eventually need them to be for installing it in your aircraft. So for example, if we're eventually going to have our ESC potentially sitting up here, it might be a good idea to orient the wires to where they are closer to this side of the shroud than this side, because you've got more wire to work with. So that's pretty much the biggest reason there. So just keep in mind as we move forward with that. As far as initially installing the motor and installing our heatsink, I'm only going to use one of the screws here. You guys will see that there's multiple holes machined onto the face of this motor. We're going to be using the larger holes, and those are M4 in size. Okay, so we'll just go ahead and tighten that one down. Then we'll slide our heatsink onto the motor. So this being the longer motor, you guys can see that it sits flush with the back of the motor. Okay, once that's in position, we'll go ahead and start tightening it down. I like to start with the middle screw here. And as we tighten these down, please pay attention to the gap that we see here and here. We want that to be roughly the same. Okay, once I have the middle screws tightened down, I know that the heatsink is not going to move or shift. We're going to go ahead and remove the motor out of the can, or out of the center body. And once we have the motor out, now we will go ahead and install the remainder of the screws. So if you guys miss this step now, it's going to be extremely hard later to get this screw into position once you guys have the full motor or the full fan all built up. So that's why it's important to knock this step out right now with the heatsink. So again, with the heatsink installed, last thing we have to do to complete this step is to take our M4 screws, get the motor back into position wherever we need it to be, and then simply tighten down all 4 screws here. Do not over tighten these, just torque them down enough to where they're not going to come loose. I've never had any issues with this. There's no need for Loctite here or anything like that. We are about 50% of the way through here, and next we're going to go ahead and put the rotor together. The biggest challenge with this, with new blades, again, because they're new, they can be a little bit difficult to install at times. Older blades, you're not going to have that problem because they've already been in position, and they're probably going to have the grooves already cut in there, and all these tolerances are going to be a little bit greater than brand new blades, which is fine. As far as the blades go, on blades that are extremely old or have any damage, I would highly recommend replacing those. These blades here are brand new, and the material used to make these has also been updated over the last, I believe, probably 5 to 10 years ago is when it was updated. So new blades will be a little bit stronger than the old ones, but as long as the old blades are in good shape, not damaged, should not be a problem with the power levels that we're going to be pushing this fan up to on a 12S system. Okay, so the first step here is to take your the washer. This is a stock piece, and you should already have it from the disassembly. It's a steel piece, so very hard to damage, but again, just clean it up. Make sure it's doesn't have any glue or any adhesive here in the grooves, because that'll make the assembly a little bit more challenging. From there, we'll just go ahead and start pressing our blades into position. Do about as much as you can here. Brand new blades are going to be hard to push into position, so it might take a little bit of force, maybe from a mallet. A rubber mallet is the preferred method to just kind of push them into position where they need to be. And then just go all the way around. Okay, that's okay for now. It's not perfect. And what I'm going to do is go ahead and use a mallet and just kind of seat these the best I can, making sure that this space here at the front is the same as we go all the way around the circumference of the fan. So I'll be back with that. Okay, so here we have the partially assembled rotor. I did have to use a mallet to seat all of these blades, and now when we look at it from the side here, we can see that they are in the exact same position all the way around, both at the back side and at the front end of this blade, and that's or at the front end of the fan. That's exactly what we want to see before we move on to the next step, which is to place our CNC machined rotor hub into the center of the fan here. A couple things to note: we have to, as we assemble this, we really need to make sure that the 3 holes on the rotor hub line up perfectly with the 3 holes that are on our washer, and realize that you guys will not be able to push this together just by using your hands. So 3 methods of assembling this. The most preferred method and the best method is to use some sort of press where we have enough force and we have the ability to apply that force at a very controlled speed to press this thing together. The next step, or the next option, would be to put it in a vise. And if you guys are going to put this in a vise, just make sure you don't damage this portion of the center or of the rotor hub, because if you do, that could potentially cause some problems as we attempt to use or collet, because this is a critical portion of this part. The final method would be to use a large clamp that has enough clearance to be able to get all the way around and to just kind of clamp this thing together. So that's probably the cheapest way to go if you guys don't have access to a press or a vise. As it is, I have a press, so what I'll do is I'll go ahead and use my press to compress this together, and I'll be back with that to show you guys what it should look like. Okay, so I've gone ahead and pressed my rotor hub into position here. As we can see, all of these holes are lined up perfectly. Our blades are still seated exactly where they were prior to this process, and the back side of our rotor hub and the blades, there should be a little bit of a lip here that you should be able to catch on, and that should be the same all the way around. So as long as all those conditions are met, it is seated in there well, and this fan should run very balanced and very true. Next, we're going to go ahead and secure this whole piece together using the included M3 screws. One note here, do not use these screws to compress these two pieces together. If you guys do that, these will not last. You're probably going to end up stripping the threads on there as we attempt to do this, and it's just not the preferred way to go about compressing these two pieces together. So once all of these are in position, go ahead and tighten them down. They don't need to be super tight. They're really just in there to provide a little bit more security. Okay, there is the finished rotor. And okay, now the exciting part, where we're gonna go ahead and place our rotor into the fan body and bring this fan to life, at least in a static manner. Okay, here is our collet that we're going to be installing on our motor first. This is machined for a 8mm motor. Should just slip right on there. And if you guys are using a het motor, just like I am here, this has been machined to accept that motor shaft, and everything is to perfect dimensions here. Once that's in position, we'll go ahead and take our fan and just drop it on, push it back as much as you guys can. And once it's in position, we can finally go ahead and get this nut on there and tighten everything down. My recommendation is to do this step last. Do not put this fan on there until you guys are completely ready to get this fan assembled, because it is kind of a pain trying to take this off, because the collet has quite a bit of grip to it. All right, so we'll go ahead and move on, get this finished. Okay, there it is. Okay, next step here will be to place the spinner on the fan and tighten it down. One thing to note on mine, I have sanded down these three stubs that correspond with these three notches that have been machined into the front washer. So for me, it doesn't matter here. I can orient this in any which way, but if you guys have not sanded it down, just make sure those match up, otherwise the spinner will not fit into position. So we'll go ahead and pop that on and tighten it down. And there it is. Well guys, here's the final product. I just tested this fan, which will be posted. The video will be posted. I'll link it in the description below. Please take a look at that. Overall, performed extremely well. Completely balanced, absolutely no vibration at all, and should be a great fan for whoever ends up using it. During the test, with the cool day that we have today here in North Texas, saw just a little bit over 20 pounds of peak thrust at just a little bit over 6 kilowatts. Last thing I want to do here is check the weight of the fan. So we'll go ahead and drop it on the scale so you guys can see what is expected on a fully built fan. All right, so we're looking at 2 pounds, 3.2 ounces. And for our European friends, we're exactly at 1,000 grams for the build here. All right guys, thank you for watching the video. Thanks for purchasing my conversion kit. I really appreciate the support, and just wanted to offer up my website, edfdynamax.com, if you guys are looking for a more powerful fan in the future, for potentially converting a turbine aircraft to EDF, or just building something from scratch that weighs upwards of 30 to 40 pounds. There's never been a better time to fly it using electric power. For example, this fan right here that I've been testing over the last 1.5 years, is capable of producing well over 35 pounds of thrust, and it will do it reliably time after time with no chance of burning up or overheating in your expensive airplanes. Please take a look at my test videos. Everything is out in the open, and I make sure that you guys know exactly what you are purchasing when you buy from me. So once again, thanks a lot. Please comment. I will read and respond if there are any issues with this video or anything else that I've made. Thanks a lot.